Hi, this is Dr. John Bergduff. In this video, I want to show you how you can use integer chips, also known as integer tokens, to illustrate subtraction of integers. So I have already created, and it's elsewhere on this channel, a video talking about how to illustrate addition of integers using integer chips. So if you haven't seen that video first, you might want to look at that video first. It would be a good background. But jumping right in, let me introduce you once again to integer chips. I am calling these integer chips also integer tokens. And as you can see, what I have here are just some black and red poker chips. There are commercially available integer chips or integer tokens, and those are double-sided little chips that are little circles that are yellow on one side and red on the other. In those commercial chips, the yellow represents positive and the red represents negative. I kind of like using black and red. Black is going to represent positive, red is going to represent negative. And these little poker chips are really inexpensive to get if you can't get a hold of the commercial integer tokens. So as I begin looking at integer chips, I want to remind you of a major idea that we saw on the first video that I want to bring up again. And that is what happens if you put together a single black chip with a single red chip. If you take a black chip, which represents +1, and combine it with a red chip that represents -1, the result you get is a 0. The way I described this in the previous video is imagine the black chip meaning that you have in your pocket $1, but at the same time you owe a friend $1. If you have $1, but you owe $1, then your net worth is $0 because you've got to pay back this other guy. So a black and a red together form a 0 pair, represent 0. Hang on to that idea, we will see it again. I want to also just remind us of what we learned from the previous video, which are some nice rules for what you do when you add two integers. If you add to add two integers, if the signs of the integers are the same, you add the absolute values of the integers and give the sum the common sign. What does that mean? Well, let's do an example that's kind of straightforward. What if we had -5 plus -4? Those are two integers that have the same sign. If I add them, I add the absolute value. So the absolute value of -5 is 5. The absolute value of -4 is 4. 5 plus 4 is 9. But the sign you give your answer is the common sign, the sign that both of these numbers have. That's a -9. Slightly different if you're adding two integers, if the signs of the integers are different. If to add two integers, if the signs of the integers are different, subtract the absolute values of the integers, larger absolute value minus smaller absolute value, and give the sum the sign of the number that is larger in absolute value. So an example there would be, say we have 4 minus -9. 4 plus -9. No, I'm getting ahead of myself. 4 plus -9. I'm adding two integers with different signs. What this says to do is to subtract the absolute values of the numbers. So the absolute value of 4 is 4. The absolute value of -9 is 9. 4 and 9. Take the larger of those absolute values minus the smaller. 9 minus 4 is 5. And give the final answer the sign of the number that's larger in absolute value. And that's important to say it that way. If I look at just these two numbers, the larger number is the number that would be to the right on the number line. That's actually the 4. But the number that's larger in absolute value is -9. And you give the answer the sign of the number that's larger in absolute value. So the answer would be -5. Now we will come back almost at the end of this video to these rules because I'm going to see a connection between subtraction and addition. But let's get back to our chips and move over to subtraction. In the previous video where we illustrated adding, we added chips by putting them together. If I had, say, 5 plus 3, that's 5 black chips, and we put it together with 3 black chips. Subtraction is going to have the idea of taking away. What do I mean by that? Well, let's start with a real simple example, an example that you really could work with students in first grade, say, or maybe even kindergarten for that matter. 8 minus 3. So what you do is you look at the first number and you start with that. It's a positive number, so I'm going to use black chips. I'm going to start with 8 black chips. There we go. Subtraction means take away. Take these 8 black chips, and then from that, take away 3 black chips. So here they go, taking those away. 8 chips, take away 3 chips, you get 5 chips. They're black, so the answer will be positive. 8 minus 3 is 5. Not to beat a dead horse, but this will help us as the examples get a little more complicated. What I had to begin with was 8 black chips. And subtraction means take away 3 black chips. 8 black chips, take away 3 black chips. And that's how I get that answer. I want to kind of have this more detailed description. It'll help me when I look at some examples where I have sort of a mixture of positive and negative numbers. Let's do another one. Subtracting a negative. Okay, now you may already know, probably do know, that there's a rule for what you do when you subtract a negative. For the time being, I'd like you to put that out of your mind. And I want you to explore this like you would if you were a little kid and we were talking about chips. So let's translate this to the language of chips, and then we'll actually do it. So this time I'm starting with -3. Now, negative would be red. So I'm starting with 3 red chips. The operation of subtraction, which is what comes next, means take away 3 red chips. Take away what? Well, the number following the subtraction is a negative number, so that's red chips. 3 red chips take away 2 red chips. That's what we're going to do. Let's actually do it. So here are 3 red chips. I'm going to start with 3 red chips, and I'm going to take away 1 red chip. To take away 2 red chips, sorry. Take away 2 red chips. What am I left with? Well, I have 1 chip, and it's red, and that's -1. Now, we may know the rule, and you might think about that rule and see if this is consistent. But for the time being, what I simply want us to do is what we would do with our kids, which is just do more examples until we feel really confident with what's going on. 3 red chips, take away 2 red chips, you get 1 red chip left. We'll look at this more carefully a little later. Let's do another one. This looks a little bit different, but let's again focus on what this is actually telling us to do. We're starting with a -8. -8 is red, so we have 8 red chips. We're subtracting, so we take away. What do we take away? Whatever follows the subtraction sign. We're taking away a 3. Now, a 3 would be a positive number. That represents black chips. So 8 red chips take away 3 black chips. Now, wait a minute. Let's see what that's going to look like. 8 red chips. Let's start with that. That's doable. 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 red chips. What the operation is telling me to do is to start with those 8 red chips and take away 3 black chips. How am I going to do that? There's no black chips here. This is where our 0 pairs come in. Because if I put a 0 pair on the table, I'm really not changing my number because all I've put in is 0. But if you notice, by putting in that 0 pair, I've brought a black chip into play in this discussion. If I just bring some more 0 pairs in, I will have enough black chips to take away. So what you do is you simply bring in the exact number of red-black pairs that you would need so that you could take away the 3 black chips that you want to take away. 8 red chips to start with. Bring in some 0 pairs, bring in just enough so that you can, from that, take away 3 black chips. There they go. When you take away those black chips, you still have the red chips left. Bring all of those together and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 red chips gives me an answer of -11. Wow, that's very interesting. We're going to have to see if we see the pattern in there. You might already, but don't jump to any conclusions. When you have to subtract away an opposite color, you bring in 0 pairs until you've got enough that you can take away. Let's do another one. 4 minus -3. Let's write down what we have. We're starting with a 4. That's a positive 4. So we're going to have 4 black chips. We're going to take away because we're subtracting. What are we going to take away? Whatever follows the subtraction sign. We're going to take away 3 red chips because that's a negative. 4 black chips, take away 3 red chips. Let's try to do that. So let's start with my 4 black chips. 1, 2, 3, 4. How in the heck can I take away red chips when I've only got black chips? Well, use your 0 pairs. When I put a 0 pair on the table, I'm really just putting a 0, so I'm not changing the number, but I do introduce a red chip. Put in enough of those 0 pairs so that you've got enough red chips to take away, no more, no less. If I put in these 3 pairs, the answer is still the same because I've just put in zeros, but I have created 3 red chips that I can take away. So I take them away. And when I take away the red chips, black chips remain. What do I have? 4 black chips, 3 more black chips. That's 4 plus 3. You might be beginning, if you didn't already know the trick, you might be beginning to see it. The 4 red chips plus 3 black chips gives me 7 black chips. When I take away the red, I still have black. Isn't that interesting? Now, if I were doing this with a class of young people, I would not be in a rush to get to the rules. The rules, these are air quotes, if you can see them. I would let them play with numerous examples where the signs are different, where the signs are the same, and just try to see some patterns. And then I'd take the answers to all of those problems and I'd put them together and say, can we begin to see a pattern? So here, in fact, what I have for you are the 4 examples we've just done. I've actually changed the order. That doesn't matter, but you'll kind of see why in a minute. And we're going to see if we can begin to develop a pattern from what we've observed from the chips. So let's look at our answers. The first one we have is 8 minus 3 is 5. That's so basic that you might think there's nothing there much to say. But we're going to come back to it because you'll see. -8 minus 3. Now, on this one, I want you to notice that the 8, if you take the absolute values, the 8 and the 3 added together give you an 11. And the sign on the answer of 11 is the common sign between a -8 and a -3. What I'm hoping to observe there is that -8 minus 3 is giving me the same answer as if I were adding -8 plus -3. Add two numbers with the same sign, you add the absolute values, that's how you get the 11, and you give the answer the common sign. Interesting. That subtraction seems to be reinterpreting itself as an addition. With that in mind, let me back up a step and think about what if I changed that subtraction to adding a negative, which is a little bit less familiar, but notice that this is going to give you the right answer. I'm adding two numbers with opposite signs this time. So when you add two numbers of opposite signs, you subtract the absolute value. 8 minus 3 is 5. You give the answer the sign of the number that's larger in absolute value. That would be the 8. So the answer is positive. Let's keep going. -3 minus -2 is -1. We saw that with the chips. But can this relate back to addition as well? Subtracting 3 was the same as adding -3, the opposite. What if I thought of subtracting -2 as adding +2, adding the opposite? What's -3 plus 2? Well, adding two numbers with opposite signs, you subtract the absolute values of the numbers. So 3 minus 2 would give you a 1. And you give the answer the sign of the number that's larger in absolute value. That's a -1. -3 minus -2 and -3 plus 2, both of those give you -1. So once again, it looks like subtraction can be reinterpreted as addition. How about 4 minus -3? Well, if the example here was not so obvious, this one sure would be. What's 4 plus 3? Adding the opposite. This number is negative, the opposite is positive. 4 plus 3, we all know, is 7. And that's indeed right there the correct answer. I'm trying to observe that subtracting can be reinterpreted as addition because that will give us an easy tool when we need to get away from using our chips. How can we state that as a rule? Well, I think what we just did exactly illustrates this. To subtract two integers, add the first integer to the opposite of the second integer. Add the first integer to the opposite of the second. So if I have 9 minus 11, I can reinterpret that as 9 plus the opposite of 11, -11. And then I can use my addition rules that say, hey, if the signs are opposite, subtract the absolute values of the two numbers, give the answer the sign of the number that's larger in absolute value. 9 minus 11 is the same as 9 plus -11 is -2. I hope that makes sense. And what you can simply do if you're kind of doubtful about that, well, you know what? Let's try it with the chips and see how they work. This would mean take 9 chips. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's getting a little crowded. Take away 11 chips. 9 chips take away 11 chips. 9 black chips take away 11 black chips. I don't have enough black chips to do that. So I'll bring in a couple 0 pairs, enough to where I really do have 11 black chips that I can take away. So these 9 and these 2, that's 11 black chips. I take them all away, hopefully without messing up the red ones too much. What am I left with? 2 red chips. And that's exactly what that illustrates. Okay, hope that makes sense. Let's do one where we have subtracting a negative. -3 minus -2. Oh, that's the same one we've already done. How about -14 minus -9? To subtract 2 integers, add the first integer to the opposite of the second integer. So the second integer is -9, add a 9. -14 minus -9 is -14 plus 9. Adding 2 numbers with opposite signs, subtract the absolute values of the integers. That'd be a 5. Give the answer the sign of the number that's larger in absolute value. That would be the negative. 14 minus -9 is -14 plus 9. That's -5. I want you to notice with that last example, and you know what? Maybe I'll do one more. 5 minus -3, subtracting a negative. To subtract 2 integers, add the first to the opposite of the second. The opposite of -3 is +3. 5 plus 3 is 8. And I wanted to do that to sort of emphasize this statement, which can sort of be thought of as like a companion idea to the one at the top of the page, because this may be more may be helpful as well. Subtracting a negative is the same thing as adding a positive. Same idea, add the opposite, but it may help you see that when you're subtracting a negative, what you really are doing is you're adding. Subtracting -9 is adding 9, subtracting -3 is adding 3. Now, those are rules that you can use, moving away from chips, to be able to illustrate subtraction of integers. These integer chips, though, are just a wonderful way to illustrate where those rules may come from. And that's so important. We don't want our kids to think, oh, these rules are just like arbitrary rules that some evil person created. There's something behind it. And I hope that helps.